Hello, and welcome to another basic frequency identification quiz. I am Ryan Black, and I will be taking you through very basic sine tone identification today. A little bit about what it is, and then I'll have a little quiz at the end. Let's get to it. If you're interested, I am doing this in Pro Tools, and I am specifically using the signal generator in order to create sine tones at various octave frequencies. The octaves or frequencies that are available for you to guess between in this very basic frequency identification are 125 hertz, 250 hertz, 500 hertz, and 1000 hertz. Right now, I'd like to give you a chance to hear what each of those sounds like. 125 hertz. Now, if you're wearing headphones, that might have seemed very loud. It is not. Often our brains interpret sine tones as being very loud, and as we get higher in frequency, there are resonant points in our hearing mechanism that amplify them even more. So I just want to warn you, as we go up towards 1000 hertz, to just be cautious with the volume level. Once again, here's 125 hertz. Here is 250 hertz. Once again, 125. And 250. Now, if you're a musician, you may recognize those as being octaves. And octaves, defined in a physics sense, are a doubling of frequency. So from 125 up to 250 is an octave. From 250 up to 500 is another octave. So in this case, oh, but lower to oh is an octave. And if you're a musician, you could potentially have a scale, ba, 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 and that will be 500, and so forth. This can be confused with harmonics, which are hold on, I got the term, integer multiples of a frequency. We're not going to go into the details there, but essentially, if you took 125, multiply it by 2, you get 250. Great. But if you take 125, multiply it by 3, you get 375, which is clearly not 500. So those are harmonics, which create timbre, which allow us to create different types of waveforms. What we are dealing with specifically today are octaves. So here is 250 hertz again. Now we're going to jump up to 500 hertz. Back to 250. And back to 500. And now up to 1000. Now, if you have ever dealt with a test signal, for much analog equipment, we use a 1000 hertz tone, which is 1000 cycles per second. I will go through them one more time, and then let's see if you can identify these basic 4 frequencies. Next time, we'll go a little further. Here is 125. 250. 500. And 1,000. Okay, let's go. Here is question number 1. Identify which of these 4 frequencies this is. Is that A, 125, B, 250, C, 500, or D, 1 kilohertz? It was B, 250 hertz. How'd you do? Let's move on to question number 2. Which of these frequencies is this? If you guessed 1,000 hertz, you were correct. All right, question number 3. Which of these 4 frequencies, I think I may have said 5 on the last one, which of these 4 frequencies is this? If you guessed, once again, 250, you are correct. If not, were you higher or lower? Often, people I have seen do these types of tests will identify 250 as 500. So if you were in that category, just kind of get your head around that. Once again, here's 250. This is not a question. I'm just re-showing 250. Okay, moving on to question number 4. What frequency is this? If you guessed 500, right on. Good work. Moving on, question number 5. What frequency is this? Do you still have that 250 in your head? 125, 500? If you guessed 125, you got it. Question number 6. What frequency is this? If you went with 250, you were correct. Good job. Moving on, we have 2 more to go. Question number 7. What frequency is this sine tone? If you went with Our basic test tone of 1000 hertz, you are correct. Many engineers are able to identify that just from how much we hear it in a studio for testing equipment. All right, here is our last question. How are you doing so far? Our last question, what frequency is this? You got it. All right. That last one, question number 8, was 500 hertz. So I hope you did well. I hope that helps. If you did not do well, if you were like, I don't even know what's going on, take a minute, rewatch the video, go through the questions again, and actually write down your answers. Make sure you're actually committing to an answer and not sort of going, well, I think, and waiting for me to say it. And realize that the ability for, as an engineer and audio professional, to be able to identify those frequencies quickly, to deal with things like feedback, which we've all heard at live shows probably, as well as to the more creative aesthetic approach of using equalizers, EQ, and filters effectively, is really contingent upon us understanding these different frequency ranges, which are a primary component of sound. So with that, I'll talk to you next time, and thanks for sticking around.